Hello everyone, I'm Santosh and welcome to my channel Learning Bits. So in this video, we'll be discussing about exactly how we are going to draw a polygon, and once we have drawn the polygon, usually the polygon will be filled with solid interior by default from OpenGL APIs. But now in this program, let us fill the polygon interior by using a scanline algorithm. Yes, that is what in today's video we're going to learn how exactly we're going to fill the polygon interior with a solid color using scanline algorithm. So I'll be not going in depth of algorithm, but I will just show you programmatically how exactly we are going to fill the interior of a polygon. And once we have done this, so let us control this fill of a polygon using a menu, either to stop the polygon fill or to continue to fill of a polygon and so on. And so now in this algorithm or in this program, we are going to keep this as a coordinate system, that is keeping the origin at 0, 0 at the bottom left corner and the right value being 500 and the top value being 500. So being in this coordinate system, now if I want to represent this as a coordinate system, so this is going to be my left edge of coordinate system and this is going to be the right edge. So now once we are going to have left edge and the right edge, so where the left edge is going to be with the value 0 and the right edge is going to be with the value 500. So now keeping the left edge as 500 and right edge as 500, because every time this is the coordinate system what I'm using, the left is 500 and right is 5, so left is 0 and the right is 500. So keeping this as a coordinate system, you can see the lines for every y value. If for the y value as 0, 1, 2, 3, 4, so on until 500, there are 500 lines. So for example, I've just put only few lines, but there will be 500 lines over here. Hence we call this as scanline. We're going to call this as scanline. That is, we are going to keep on scanning line by line and we'll start filling the polygon or filling the complete background. That is what we call this as scanline. So now this is the scanline 1, scanline 2, scanline 3 and so on. I'll be having the scanline until 500. So now keeping this as scanline, if there is no any polygon, if I want to fill the entire background, I need to start drawing the pixel with the color what I want to have the background, starting from this value as 0. I'll be keep on filling until this complete scanline. Then I'll move on to the next scanline, starting at 0, fill until 500. Go to next scanline, again initialize to 0 and fill 500. For every y value starting from 0 to 500, I'll be filling the x value from 0 to 500. Now this is what exactly the setup of scanline we talk about, the scanline algorithm we talk about. And now if there is any polygon, now if I want to fill only this polygon, now just look at this. So now the polygon and the scanline, if you just observe, there is going to be intersection points. So this is what I need to find it now. I am going to find the intersection point, and wherever the intersection point is going to be. Now if I talk about this particular scanline, now this is the left intersection and this is the right intersection. The left intersection, the right intersection, the left intersection, the right intersection. Hence for every scanline there is going to be left and the right intersection points. That is, the intersection is with the edge of the polygon and with the scanline. Hence if you just check out this, the intersection point for both left and the right is same, and there's going to be only one point or it has been overlapped. Hence now in this term when I'm going to a scanline, and if you are able to find the intersection point, then when you're filling the polygon, you need not fill all these lines. You need not fill these lines because this is background. I need not draw any pixel over here. But when I want to draw, I should draw from left to right in this scan line, the left to right in this scan line, the left to right in this scan line, and so on. So in this particular left to right scan line, I should be keep on filling this edges. So this is where we are going to talk about the scan line fill algorithm. The scan line fill algorithm will find the intersection point, the edge of the polygon along with the scan lines, and by intersection point it is going to find what is the left value and the right value of a particular scan line, and it is going to fill only those points between the left and the right. So that is what we are going to bring into the program, of how exactly we are going to find the left value and the right value for a particular scan line. If you are able to identify this intersection point, then you can fill only those lines where the left and the right value is going to be between the polygon area. If I do it for every scan line, the complete polygon will be filled. That is the idea behind how exactly the scan line is going to work with. And so now to do this, I am just going to consider a polygon of the type rhombus, and these are the points which have been identified in my coordinate system, and I'll be using the same in my programming. And so now we will just shift back and we'll see how exactly the programming of this scan line will be done in OpenGL program. And in this OpenGL program, so the basic APIs which we usually need to have, and if you want to have in depth of what all this API is going to do, you can please check out my previous video where I have just told what are the basic details you need to understand about these APIs. Fine. So now just to go ahead with this, now I want to draw a particular screen or a particular polygon, but before that, so just check it out. I am using GLE Ortho 2D, so that I am just going to have the coordinate system where the left is going to be 0 and the right is going to be 500 and the bottom is going to be 0 and the top is going to be 500. So keeping this as my coordinate system, let us move on. So now in this draw function, I will just show you right now how exactly we are going to fill line by line to fill the entire background. And later on I will just shift and I will just show you how exactly to draw a polygon and to fill that particular polygon. So now just check it out over here. So now whenever I just want to fill the entire screen, let me use the for loop. So for, I will just say it as x and y. So this x equals 0 and x less than 500 because there are 500 points in the x-axis, and x plus plus, and I'm just going to have one more for loop. So where I'm going to have y equals 0. I'll just say y equals 0. Again, there are 500 points in y-axis, and so y is less than 500 and y plus plus. Fine. So now when this is done, I'm just going to draw every value what I'm going to have as GL begin. I'm just going to have GL begin, and where I'm just going to draw just a points. I'm not going to draw any lines over here. I'm just going to draw points, and this should be ended with GL end. And I'm going to use GL vertex. To I, because this is going to be an integer, and so I'm using 2i, and the first value is going to be x comma y, and the first point whatever I'm going to draw, it is going to be at 0 comma 0. So right now just think, my entire background is black color by default because nowhere I'm setting the clear color. Hence when I execute, my entire background should be black color, but I'm drawing the points in every value of x and y, that is 0 comma 0, 0 comma 1. It is kind of a matrix now for me, a two-dimensional matrix. And so now when I'm drawing this entire thing, you should have a screen where the screen will be filled completely with the color white. And let me declare this variable, and I'm just going to compile this and execute. So you can see the complete background is filled with the color white. So now just for better understanding, let me show you how the filling is happening. Let me show you how the filling is happening. And to see in slow motion, kind of slow motion, if you want to see how the filling is going to happen, so just copy this GL flush and place it at the loop itself. So identify the point and draw the point, immediately put it on the display. Go back, identify the point and immediately put it on the display. And every time I'm drawing it on display instead of doing it one time, I'm keep on doing this. And so now when I compile this, when I execute, so you can see the filling is going to happen. Filling is going to happen line by line. But one problem here, what you are seeing is, actually I told you the scan line is with respect to y-axis. I am going to have first scan line, second scan line, third scan line, so on. Hence the y should be the major axis now and x should be the minor axis. But in this case, well, I started programming, I made the x to be the major axis and y as the minor axis. That's the reason why the filling is happening from left to right. But the filling was supposed to happen from bottom to right, keeping the y axis as the major axis. And this is the reason why the polygon fill algorithm will make the y-axis to be the major axis. Hence in this regard, so if I want, I can change the value as y over here and I can change this as x and I can execute this. So now this is going to start filling from bottom to top. But this is not the right way of doing with the scan fill algorithm. Because so nowhere you're making the y as the major axis. You're making still the x as major axis only by flipping the value of x and y. You are using a trick to make sure it is going to fill from bottom to top. But as per the algorithm, so this is going to be x and y. Instead of flipping these values, flip the major and the minor axis. Hence I'm going to make this as y. It's going to be y and this should be y. And this is going to be x. So now when I execute, so without any doubt, you need to have the filling from bottom to top. Fine. So by this way, it's going to fill the entire background with the color white. That's fine. So I hope at this point of time you are clear enough. So now we'll just go ahead and try to bring in the algorithm with the intersection points. But before that, some sort of modifications I will do, which will help me in building the algorithm. Fine. That one sort of point is, now I'm just going to declare. I'm going to declare an array called as left edge. And how many points are there in the y-axis? It is 500 points. Hence, there are 500 values. If I say one scan line, left and right, there are two intersection points, maybe or two edges. The second scan line, again two more left and right. Again scan line, two more left and right. Hence, so if there are 50 scan lines, I'll be having 50 left edge and 50 right edge. But in our example, there are 500 scan lines, hence there should be 500 left edge. Hence, I'm declaring an array as right edge with 500 and left edge also with 500. Fine. So now what is the left edge value is going to be? So it's going to be 0, because when I say left edge, it is going to be 0 and the right edge is going to be 500, and there are 500 scan lines. And now for that purpose, I'm just going to use a for loop. So for I equals 0 and I less than 500 and I plus plus. So now what the left edge value is going to be? Now every left edge value is going to be 0 for all the scan lines, and for all the scan lines the right edge value is going to be maximum value, that is 500. So now instead of now saying y equals 0, so now I'm just going to replace this as y equals 0 and y is less than 500. That is for every scan line. Now this x value should be filled from the left to right. The x value should always fill from left to right. Hence I'm going to start the left value from the left edge. That is, instead of having 0 here, I'm having left edge of 0 over here. And now even this I can replace as right edge of 0. Hence for the first scan line, this is the first X value what I want to fill. So starting from left edge to right edge, entire point should be filled. That is what this loop I'm going to do about here. And this is only for the first scan line. What I prefer second scan line, the left and right need not be same. It may change. Hence, instead of using this as 0, let me say this as Y. That is the white scan line. For the white scan line, the left edge and the right edge. So now once I execute this, now this should be the same output. I should declare a variable. Let me say this as I. So compile this and execute. So it's filling it again. So this is what I'm moving towards the scanline fill algorithm. And now once this is done, what's my next job I should do is I need to bring in the polygon now. Now this is the filling is happening properly, but now I should bring in the polygon. I need to find the intersection point and I need to update the left and the right value. So now for this purpose, I'm just going to draw a polygon now. So to draw the polygon, I'm just going to use this as the polygon in my program. Hence, I'm just going to declare the variable as GL int, and I'm just going to say P1 point which has two values X and Y, and so I'm just going to have 125 comma 250. This is the point what I'm talking with. And next I'm going to have second similar point, and let me copy this, and I'm going to have 4 points. Fine. So now this is P2. So P2 is, this is the point what I'm going to consider now, 250 comma 125. Hence I'm going to have 250 and this is going to be 125. And this is going to be P3, which is 375 and 250. And this is the fourth point, that is P4, which is 250 and 375. Fine. So now all the 4 points I have just made. So now let me display this. So to display this, I'm just going to use so this is GL begin, and I want to draw it as a polygon, and so GL polygon, and so GL end. So in between this, I need to draw the polygon. Hence, I'm just going to use this as GL vertex. So it is integer, and so 2i. I can pass it as an array itself. Hence, I'm going to use P1 and copy this P2, P3, and P4. And this is going to be P2, P3, and this is P4. Fine. So now let me compile this. It's fine. If I execute, now you can just see a polygon over here. But by default, as I told you, your OpenGL program primitive will fill the polygon with solid color. But right now, I don't want to fill anything in this polygon. And so instead of drawing this as a polygon, let me draw this as outline of the polygon. I just want only the outline of the polygon. And for that purpose, I'm just going to make this as GL. Only for the outline, I'm just going to use it's a GL line loop. Use this as GL line loop. Save this and compile. So now this is going to be, now our job is I've done with the polygon. Now I should fill only the interior of the polygon. But just observe, the background is also getting filled. I don't want to fill the entire background now. I just want to fill only this polygon. Wherever the intersection of my polygon will happen with the scan line, that is where the filling should happen, not this entire background. Hence I need to have the left and right valid values for the left and right. So to do that, I don't want the filling to happen at this point because there is no any intersection. And so by default, let us make this condition to go false. That is, I don't want this statement to be executed for particular scan line which doesn't have valid left and the right value. Fine. So now for that, I just want to make intentionally this condition to be false whenever there is going to be a scan line without a valid value. Hence for that, let me make this as 500 and this as 0. Now let's check it out. For all the left value is going to be 500 now. For all the scan line, the right value is going to be 0. So 500 is less than 0. This is not executed. So it's not a valid x and y value to fill the line. And again for the next line, the same case. For now, for all the scan lines, it's going to be the same case. So no filling is going to happen. Fine. Now if any filling should happen, so now whenever there's going to be intersection, this is the time where I'm going to get valid left and the right value, where the left value is going to be less than or equal to the right value. Only in that case we'll say it as a valid, and whenever the left value is greater than the right value, it's an invalid to fill or need not fill that scan line. That is what we have done by changing the value of left and right from 500 to 0. Now this is done almost. So now my next job is I need to find the intersection point. Now to find the intersection point, I'm just going to have an user defined function. So let me have an user defined function called as intersection. I'm going to have the file name as or a function name as intersection. So now whenever I want to find the intersection for every line, I'm not going to find the intersection for the entire polygon at a time. I'll just take line by line or the edge by edge of a polygon, and for each edge of a polygon I'm going to find the intersection. I'm going to update the left and the right value. If I give only one edge as the intersection, the left and the right will be same. Left and right will be same for all the scan lines. It's fine. For all the scan lines, the left and the right value will be same if I'm giving only one single line. Even if I give 2 lines, something like this, for all the scan lines, the left and right will be the same value. When I give some edges like this, then this is going to be the left value, this is going to be the right value. That is how the intersection should be found. Hence for every single edge, I am going to find the intersection. So if I want to have one edge of a polygon, I need to pass the 2 points as a parameter. Hence I'm going to pass P1, P2, then P2, P3, P3, P4, and so on. Hence I'm going to pass P1, that's the x value of P1, and the y value of P1, that's the first point, and the x value of P2, and the y value of P2. I'm going to pass this as the intersection value. So now let me have this as a function. So void intersection, so which takes 4 parameters, that is GL float, or it should be int. So GL int x1 and x2 y1 y2. And so I'm just going to copy this out. This is going to be y2, and this should be x2, and this is going to be y1. And so now in this function, when I want to find the intersection, I need to find the intersection with respect to every y value, but I'm going to use the slope of this x-axis. So using the slope of the line, I'm going to find the intersection of a given scan line. I need to even work with the slope. So increment the value of x by slope value for every increment of scan line. When I increment the scan line, you need to increment the value of x along with the slope of the line. Hence for that, every time I start from the y value which is going to be at the bottom, and we'll try to increase, the y value should increase. So sometimes when I'm going to give the P1, P2, if this is P1 and this is P2, then the y value will be greater than y value of the P1 will be greater than the y value of P2. So which should not be the case. So now whenever you're going to talk about a line, this should be P1 and this should be P2. If I am giving it reverse, if the y1 is going to be greater than y2, you need to swap this. And the first condition is you need to check whether the y1 is greater than y2. If this is the case, if this is true, I need to swap the points. So from P1 to P2, I need to swap it out. If the condition is false, it's fine. You can just go without swapping. And so to swap the points, I'm going to swap both the x and the y value. And so I'll be using t x1, and I'm going to have this as x1 equals x2, and I'm going to have x2 equals t. That is, as usual, the swapping operation. So similar to this, I need to swap even the y value because the entire point should be swapped out. And so I'm going to have t equals y1 and y1 equals y2 and y2 equals t. Fine. So swapping is done. So once I have been fixed this p1 and p2 to be at appropriate increasing y value, my next job is I need to find the slope. So to find the slope of a line, which I call this as m, to find the slope of a line, the formula what I'm going to use is, so x2 minus x1, so this is divided by, so y2 minus y1. So now what if y2 and y1 both are same? For example, if it is a straight line, what happens for y2 minus y1? This becomes 0, and anything divided by 0 is going to end with an runtime error. So just to manage this error, I am going to put a condition, so y2 minus y1. So if this y2 minus y1, if this is going to end with 0, this ends with 0, then the slope is going to be x2 minus x1. So no need to divide this. Else I'm going to use the slope with the as usual formula. So right now I have founded the slope also. Now my next job is, with the slope, you need to find the intersection. So to find the intersection for every scan line, I need to find the intersection. So for that, I am going to have the for loop. I am going to have for loop for the y as the major axis. So from y equals 0, or so instead of finding intersection for every y value, I can start from the line's y value. It is y1 to y2. Whatever the line I have got, because I know there won't be any intersection for all these scan lines. The intersection will start only from y1. Hence, we'll say y equals y1 instead of starting from y equals 0. And I am going to reach until y is less than or equal to y2. And this is going to be y plus plus. Fine. So the loop is going to be for y value, and now the x value is going to start. So initially I'm going to start the x value intersection at x equals x1. That is, if this is my line and if this is my scan line, I'm starting at y1 and this is the x1. So there's going to be the first intersection will be at this point, the x1 itself. Hence I'm going to say x equals x1. The first intersection point itself is that. Hence I'm going to say x equals x1, and I'm going to check whether any left value right now, whatever the x value I have been found, if this current x value, if it is less than the left edge of the particular scan line. Now what is the left edge of particular scan right now? It is going to be 500. Hence, if there is an intersection of x somewhere in between, so obviously it will be less than 500. The condition will become true, and the left edge of y will have a new value, whatever the current intersection of x with the scan line y is going to be. So similarly, if the value of x is greater than the right edge of the value y, if this is true, then right edge of the value y particular scan line is going to be x. If it's one single line, so right now the value of right edge is 0, If it is somewhere in between this x-axis intersection, then this condition should be true, and I'm going to assign this y value. If it's single line for a particular scan line, now you can observe both the left and right will be the same value. If I give one more edge, the left edge will remain same, only the right edge will be updated for a particular scan line. So this is what you're supposed to do. And once this is done, I'm just going to check for the next scan line. But before going for next scan line, you need to increment the y value also. And the y value be incremented or decremented depending upon the slope what I have been found. And so hence x equals x plus the slope value what I have been found using m. So now if I'm just going to process this, so this should do my job, but there are few variables which I need to declare. So let me declare this as float. This as float values. So I'm be using x, y value, and the slope value m, and I'll be using any other variable as I'm using the t. It can be integer and any other values. That's it. So now this is going to be the variables which I'm going to use. So let me save this and compile this. There is error now, and the error is x is less than edge of y. Now what error? I'll just check in the logs. So if I go for logs, so RE undeclared. Yeah, so left edge and right edge are undeclared. So we'll just make sure this is going to be the global declaration. We'll make this as the global declaration and save this. Now compile, and there is few more errors. We'll see out the logs. Array subscript is not an integer because I'm using y over here. So so now y cannot be float. I need to make this as an integer. So now just check it out. Add 0 errors and execute this. Fine. So right now I have just passed only one line, hence you won't see any filling over there. So similarly for all the remaining 3 edges, so now I'll just pass the second edge and check it out what is going to happen. For only one edge, if I find intersection, you'll be seeing only one line, no filling at all, because the right and left is same for all the scan lines. If I give this second edge, then this half of the polygon should be filled. So we'll see how this is going to work. So just copy the same function, but now pass the second edge. The second edge is between the P2 and P3. And now we'll just compile this and execute. Yeah, you can just see the filling is going to happen between these two because the left and the right has been updated. So now this is not happening because I have not given the next edges. If I give the next edges, this is going to work fine. So hence, so let me give another 2 edges also. So this is between P3, this is between P3, and this is going to be P4. And now this is going to be P4 and this is P1. Right. So now let me save this. Now this should work for me now. Right. So now the polygon is going to fill between the edges what I given by updating, and so you can give any sort of shape, but make sure you use convex polygon instead of using concave polygon. So this is going to be the scan line fill algorithm. And as I told you at the beginning, along with this, so I'll be just bringing the menu concept also to have the edges. Either I need to have an edge of a polygon, a separate edge where I'm going to draw. So let me do that. Let me draw the edge of a line. Now this is going to fill. So now I'm just going to copy this, and after fill operation, let me draw an edge by using a different color like GL color 3F. So I'll just be putting this into the menu operation, whether I need the edge of the fill or I do not need the edge of the fill. So for that reason I'm just going to use this, or instead of having this, So what we can do is, anyhow I am going to draw the edge over here. Even if I don't draw this, that is, let me comment it out. Fine, let me comment this out, and if I execute this, so there is no edge, but the filling is going to happen. Hence, while bringing the menu option, we will see how exactly either you need the exterior or the outline, then you should start filling, or without outline you need to add the filling or not, whether you need the outline of the polygon or not. Fine, and so we'll bring in that control system with the menu operation. Hence now this code should be controlled now, and for that we'll say if edge flag equals 1, then I need to draw the outline of a polygon, and if it is not equal to 1 or something like 0, I need not draw the edge of a line. Fine, that is what I'm going to do here. So this I'll be controlling with the menu option. Hence I need one more variable now called as edge flag, so which is going to be initially 0. If I want, I can change it to 1. By default, what I'm going to do. So now let me bring in the menu option. So I'll just go to my init and I will say GLUT. So create menu, and let me give this as menu over here, and GLUT. So add menu entry. So the label what I'm going to give over is, so with edge, and let me use as 1, and the next menu entry is going to be, so without edge, and let me use as 2, and the next menu entry is going to be exit. So even you can use the menu option to give the color of the edge also. If you want to change the color of the edge, even you can do that. Fine, and so I'm just going to have this menu option, and I need to attach this menu for a mouse button, and so GLUT attach menu. I'm going to use GL, so right, I think GLUT, so right button. So save this, and the menu function should be defined now. And so I'm going to have a user defined function called as void menu, which is going to take an integer as an ID, and so I'll use as int ID, and if ID equals 1, then edge flag should be equal to 1, else if the ID equals 0, if it is equal to 2, then the edge flag will be equal to 0, shares to 0. Else if ID equals 3, I'm going to exit from the program, and exit 0. And for whatever we are going to have, I need to update the display, and GLUT post create display. So just done with this, and we'll just see how the menu is working out. Execute, because once the fill operation is started, until this is going to finish, you cannot select the menu operation. That's the problem what I'm getting here. Let us start the filling only after choosing the first option, and for that purpose we are just going to halt the filling. So for that, when the filling should happen, that is this entire thing again I should put into control. So if fill flag equals 1, so only then we need to start filling the polygon, or else I need not start filling. I'm not going to start the filling until the fill flag will be made to 1. Hence the fill flag initially So fill flag initially, let me make it as 0. Fine. And now once I am going to choose any of this option, once I choose any of this option either with edge or without edge, only at that point of time, so this fill flag should be changed. Hence we'll go to the menu option. So in the menu option, let me change the fill flag. So fill flag will be made 1 only after choosing the option. So we'll see how this is going to work. And execute this. Fine. And now we'll just go to the menu and we'll say with edge. So the filling is going to happen with the edge. Fine. So this is how exactly we are going to bring in the concept of menu option in your program. And there are 2 flushes now, if you remember. And without edge, so this is going to work fine. Fine. So now this is going to work with the menu option. So when it is going to have with edge or without edge, hence I can bring in the concept of menu also to the program. And next is if I say exit, this is going to be the program. So this is all I wanted to discuss in this video. Thank you. Thank you for watching. And if this video was useful, so please do comment and like it. And for more such videos, please do subscribe to my channel.